Thank you so much,
Uh,
Professor Simanthani, for joining us. I'm very excited for Arpita's activity myself and will be participating in the same.
okay. So I think we'll start with what the learning outcome of the course will be before we get on to the activities. So, like, this course will essentially explore the different neural mechanisms that underlie different behaviors and different emotions, and how the neural mechanisms in turn shape our behavior. So, we'll basically go into in-depth neuroscientific research into how our body regulates stress, how we can deal with stress, and build emotional resilience when we face stressful situations, and basically not just stress but different kinds of like other various kinds of emotions as well, such as happiness, sadness, and so on. The course has extended learning opportunities, such as like you'll obviously get a course completion certificate after you've successfully finished the course, and the top three students who finish the course will get letter of academic achievement from the faculty, and selected students will also get an opportunity for an observationship with Professor Simantini Ghosh, and through in which they will basically learn through observations and reflections under Professor's guidance. So the way I have planned this, planned the session is such that like we'll get a very quick glimpse into how the course is going to look like over the summer. So we'll get started with the fundamental building block. Sorry, I don't know why my screen is frozen. Is it frozen for you guys?
It unfortunately is. Have you tried to
Yeah,
move on to the
it
next
is not
slide?
moving.
Oh, okay. Okay, yeah. So we'll
No,
start
not at
with the
all.
build. Okay. So we'll start with the building block of the nervous system, the nervous system is basically built by these cells called the neurons or nerve cells. And these are specialized cells that are in our body that are basically involved in transferring information from one part of the body to another. So these cells are uniquely structured so that they can do their function, and the brain sends electrical signals and various messages from one part of the body through another with these cells, which are structured like this. So we'll basically have a look at this link, which will like give us a glimpse of how a neuron looks in an interactive model. Is this visible? Oops, yeah. Okay. So this is how a neuron kind of looks like. And so it has different parts, and it is built such that it can transfer information from one part of the body to a further distant part. So the cell body of the neuron is known as the soma. This is the central part. And when I click on it, you can see that it's labeling as the soma. And these branch structures are known as the dendrites. These dendrites essentially receive information from different parts of the body to the cell body. And once the information is received, it transfers the information to different parts of the body through the help of this long structure known as the axon. And from the axon, the information travels down these another set of branch structures called the axon terminals, and then it travels to the other neuron basically. So you can see how one neuron is connected to the other, and it forms essentially a very dense network a very compact and dense network through which information travels from one part of the brain to another. And you can basically respond to behavior or respond to stimuli when the message has gone from one part of the neuron to another and it reaches your muscle muscular system, and then you can basically respond to the stimuli once the information is processed in the brain with the help of these neurons. And obviously, like, I'm giving a very simplified structure of this, like very simplified explanation, but like we'll go into like greater depth of how this occurs, how like the information travels through the neuron, which is itself very interesting and complicated. I'll not go into like the details of it, but that is something that we will explore throughout the course. And we'll be using similar interactive models in class to go over like the different parts of the brain, how various emotions like are processed in the brain, and we'll be using fun activities to basically understand that. Okay, so going back to our slide deck. So the first activity we have planned is called the neuromyth or neurofact activity, for which I'll ask everyone to like scan this QR code so that we can begin the activity. Once you have done that, like let me know, we'll get started.
I've also put the link in the chat box in case that might help you out instead.
What do we just submit what we when we are done directly, or
Yeah, you can do that. Has everyone like finished submitting their responses? Okay, so I think 6 people have already responded. And like if someone could just unmute and just talk about why they think it's a neuromyth or a neurofact, that would be like really interesting to like hear what you think. Like anyone can unmute and speak. It's just free discussion if you like.
I can start. I mean, I clicked on your truth because that's what we've always been told, right? That stress is always bad for you, can create so many issues, raise your blood pressure, worsen your health. I think I really have a
Yeah. Yeah, that's true. Like we are always told that stress is not something that can be useful, but
Mhm.
yeah, let's see what it is. But like who thinks like it's a neuro truth or sorry, neuro myth?
Can I say it?
Sure, yeah.
So I think that stress also releases a lot of dopamine and adrenaline. So I don't think that's necessarily bad for your body in controlled amounts.
Mhm.
So I think that's a myth.
Yeah, so like it's actually a neuro myth because stress is not always bad. A little bit of stress is always helpful in preparing to act and in doing the activity itself. But intense amount of stress can be harmful. Like too much of everything is not good, right? So even a lot of stress is not good, but controlled amount of stress really helps in focusing on the activity that we are supposed to do. And it kind of regulates learning and helps reach the goal, for instance. Okay. What about this? Taking rest means you're lazy. Okay. Great. I think everyone thinks it's a neuro myth. Could anyone like unmute and say why you think so?
Okay, so I would like to share. So, hi, I'm Sheetal, and I think
Hi.
that it is a myth because, uh, resting doesn't mean we are lazy. It means we are just like giving time to our body to recover and like to recover the energy for the day and all. So, I don't think it is like it. It means we are lazy.
Yeah. Yeah, so that's correct. It's absolutely like a neuro myth because it's the time to recover, as Sheetal correctly pointed out. Okay, so moving on to the next question. What do you think about this one? Okay.
I do have to say, I think this one question is kind of like a googly. Like, I think we're going to see very split responses on this one. So I'm very excited to see what everyone thinks. For new joinees, I've put up the link in the chat box. You can actually participate in the activity if you just click on that link and let us know what you think. Post submitting your vote, you can unmute and let us know what is the reason behind your thinking as well. I think this one we can debate all day long.
Yeah. Like, just feel free to unmute and speak whenever. This is like not an assessment, it's just a free discussion, so feel free to interact. Okay. Yeah, just whenever you're ready, just unmute and like almost 50-50.
We can see a lot of opinions forming, but them not being shared. I'll get the ball rolling with what I think. I voted for Neuro Truth because I think that doing multiple things together and having our attention split and being able to train that muscle might be good for us. And I'm hoping that we don't get evidence that that's not true. I'm really scared for this answer because multitasking is half of my life right now. But
Yeah.
I'm wondering what the students think because I think students have a lot to multitask over as well. So, what do you guys think? Please share.
And at this point, I think this answer, I would love to hear what people's own experiences are when they are trying to like kind of juggle things back and forth, between sports practice, the homework, the pressure to socialize, and also, keep up with your family's expectations of you. All of these things are what make up your experiences. So, it's better to have an open floor discussion about these ideas. So please unmute and just share your experiences with us.
Yeah, please.
If no one is answering, so I would like to answer.
Yeah, please go ahead. Thank you for
Yes,
volunteering.
Sheetal, please
Yeah.
go in. And I would like to also tell the other participants that at some points our teaching instincts are going to kick in and we'll start calling your names to loop you into the discussions, which is something we sometimes need to do as instructors. So please, there's no grading, we are not looking for a right or wrong out here. This is a listening circle, first of all. So let's fulfill that um, condition and open the floor up for discussion.
Yeah.
Yeah, so like according to my experience, I choose that this is a neuro myth because it happened with me. I don't know about others. Like when I used to do multitasking, so sometimes I like get stuck on something or I take lots of stress. So that's why I choose the neuro myth.
Interesting. What about others?
Can I try?
Sure.
So I picked neuro truth because I think that multitasking, it is a form of like we're engaging your brain a lot. Um, but I think that it's like a practice for when we have large amounts of stress. So you sort of know how to handle that. And I think that it makes us smarter in the long run, if not in the short run. So I think
Hmm.
that's the truth.
Do you think it makes us faster as well?
Well, yeah, faster in the short run because we get more work done.
Hmm.
I don't know.
Nice. Yeah. Does anyone else have anything to say? Okay. So, like, I think the answer is like pretty. I think everyone covered all the points. I think it can be considered to be helpful, but some people think it's a neuro myth because multitasking is often like switching attention from one task to another. And it sometimes can make learning slower and it can be tiring as well when you're trying to focus on two different things at once. Like some research does say that it reduces the quality of work you produce and so on, but like we'll go into how multitasking like impacts your brain circuit functioning like in class in more detail, but according to me it can be a neuro truth and a neuro myth, and we'll talk more about why that is in class. But for now I think both parties are correct.
Yeah, and I
Yeah.
think this is a subjective answer. And what do
Yeah.
you define? Like Isha just said that, multitasking is my life. So in a larger
Hmm.
scope of things, so is it true for all of us? I mean, we all play different roles. We all fulfill different functions through, say, the 24 hours of every day. But at the same instant, if you are parallelly asked to write a brief and crunch some numbers on your screen as you are writing, you're also asked to interpret data. So, how do you define multitasking? And this is, I think, a very interesting and important principle in psychology in general is that we are obsessed with defining and measurement, and everything that we are trying to define and then measure are abstract concepts. So that's something, you know is what I talk about a lot in the lectures of the course, but something to maybe put a pin on and then move from here.
Yeah, absolutely. What do you guys think about this one?
I have to admit, I have gone against all of my formal training in psychology and given my answer for this one, simply because something that we're fed all the time, that I think good well-being does mean being happy. So I think at this point, I have come to agree with it, regardless of what my books have told me. So I do want to share that, but I can see that all of the participants are much smarter than I am and have gone the other way. So I want to know what guided your thinking. I'm hoping that the next generation has been going through life a bit differently, where we're not being constantly told that happiness is something that you're going to have all the time. But really curious as to what you guys think.
Yeah, feel free to unmute and speak whenever.
Yeah, it would also be great to hear some other voices. So I know Sheetal and Riddhi have already spoken. So Tanishq, Kia, Sana, Anvika, feel free to join in the conversation. This learning circles are more fun when everyone pitches in. There is no right or wrong out here. We present some of the research findings, but a lot of this stuff is also dependent on how you process it and how you experience it.
So, can I give the answer?
Sure.
So, I am Tanishq, and I think it's neuromyth because well-being mind is well-being is not about smiling all the time. I think healthy mind can feel happiness, stress, sadness at all time. All emotions are normal part of life.
Mm-hmm. Yeah. Anyone else?
Okay. Yeah, I would like to add
Sure.
in this as well. So it's like, but I feel that all emotions are important for our life, and we should embrace those emotions. So I think being happy all the time is, I don't think it can be the sign of good well-being, but like embracing all emotions and like accepting those emotions are also a part of well-being, I think. So yeah, that's a neuromyth according to.
Great. I think we got like great perspectives from both the speakers, and it's actually a neuro myth because well-being is not about like being happy all the time. And it also depends on like what professor mentioned, like what do you think happy is? Like how are you measuring happiness even? And what do you think well-being is? How you like define them is also very important in understanding if it's even related to the other concept, which is well-being. So that's that aside, but well-being is about dealing with your emotions, dealing with stress, reaching out for support, having a proper balance between work life and restfulness. So all of that includes is related to well-being. So being happy all the time, happiness may be a measure of an indicator of well-being, but well-being is related to several other concepts as well, such as the ones that I just mentioned. Okay. What about this one? Okay. Yeah, you can unmute yourself and like tell us like why you think it's a neuro truth or a neuro myth. Like we want to hear from you.
Anvika, were you trying to say something? I think I saw a glitch. In case you were, please let us know if you're facing any issues in unmuting yourself. You can also write your answer in the chat box as Sana did.
Oh, I can't see the chat box. If anyone can like.
Yeah. So Sana had responded to the previous question where she just mentioned that she thinks that it's a neuromyth because having a good well-being means being healthy, not being happy, which is essentially what we did come up to as well.
Mm. Like who thinks it's a neuro myth, this one? Like we can start with that maybe.
I think neuro myth mainly because I factored in learning through repetition. So just because of that, I'm confused about the definition of the question itself. So that's why I pointed in that.
Okay. Anyone else, just feel free to unmute, please. Do we have any responses in the chat?
Not as of yet, but I'm going to give them a minute to type it out as well because it may take a bit longer. So we're looking
Okay.
forward to your inputs.
Yeah, I'm also keeping an eye on the chat, but I don't see any new message.
Do we just ask people to speak then?
I think that's what we'll have to turn to. Tanish, maybe do you want to put your input in this? Did you choose neuro truth or neuro myth, and what was your backing behind the same?
So I think it's neuro truth because sorry, because every time we learn something new, so the brain builds better connections between our brain's neurons.
Yeah, that's a great start, I think. And that's something that I was going to point to as well.
I have a
So, sorry?
I have a question.
Sure.
So does like can you please go to the previous slide? It's possible.
Yeah.
Yeah. So does neural connections mean like the placement of nerves of neurons or
No, here we are not really talking about the specific location or placement, like we are talking about the connection between them.
oh,
Yeah.
okay.
So, like, this is a neurofact or a neurotruth because when we are learning something new, like we do so by some connection strengthening or weakening, and then reorganization of the strength of the connections between the neuron. And that happens through a process called neuroplasticity. And that's how we learn new information. So when you practice something by repeating it like several times, some pathways become stronger and some pathways become weaker, and that's how you're able to learn new information. So that's another very interesting concept and a big part of what we'll explore in the lectures and in the activity sessions. Okay. What do you think about this one? Yeah, now like as before, like whoever's comfortable, just start like talking to like telling us about what you think and tell us why maybe. Who thinks it's a neuro truth?
I think it's a neuro truth because um, exercise releases a lot of hormones that are good for um, like the brain, and also because there is better blood flow to the brain
Yeah.
and you can work faster.
Yeah, that's, I think, a great start. Anyone else? Like, why do you think it's a neuro myth? Anyone?
So I did that neuro myth because I think like yes, exercise is important for our mental and physical both health and function. But I think like I don't think high intensity exercise can improve it. Like yes, they can, but not always. So I think like certain level of exercise or certain intensity of exercise is important for our health. But I don't think like high intensity exercise can. So that's why I did the neuro myth.
Fair, yeah.
Arpita, we also have two responses in the chat box. One of which says, where Tanishq is sharing that I think it's a neuro truth because exercise increases blood flow to the brain and can improve focus, memory, and mood. I'm not a biology student, but I have read about this before. And then we have Sana sharing that maybe because doing high intensity exercise involves the brain and brain processes a lot, maybe it improves mental function. So maybe it's a neuro truth.
Yeah, I think both of you are correct. And someone mentioned that high intensity is not really necessary. I think that's also true to an extent. So depends on the like kind of like what exercise you're talking about by doing like like low intensity exercise that someone mentioned. Like it can definitely like improve mental function. For example, some people say that yoga like improves like mental functions, right? Depends on the kind of yoga you do and things like that. But exercise itself can improve mental function, as someone correctly pointed out, by increasing blood flow that in turn like supports how you feel, like it supports or enhances like how your memory is and how you think and so on. And exercise is also very important in reducing stress and improving our physical well-being as well. Okay. What do you think about this one? Oh, wow. Yeah, like before, this is an interactive session. Just unmute and speak. It's like we'd like to hear what you think.
Okay, I'm just gonna go. My name's
Sure.
Andika. I don't think it makes you smarter because I mean, there's like no logic to it in my opinion. Like, how does music just magically increase your IQ, right? But like, it does, I guess it kind of like helps improve the mood and like, stimulates your brain or maybe something like that. But I don't think it makes you smarter.
Hmm. I feel
I
so
guess
too.
I'll read out Sana's reply from the chat.
Okay.
Uh, Mozart is music, right? So I don't think it makes you smarter, quote unquote. But like listening to Mozart while doing something might make you more focused and relaxed. I'm not sure. I think it is a neuro.
Great. Yeah.
And I'm sorry, I missed who was speaking. Who get the last answer?
I think it was Avantika.
No, it's
Anvika.
Anvika.
Anvika,
Anvika.
sorry.
Yeah, that's
Yeah,
right.
Anvika, I think you also gave us quite a lot to unpack right there. Um, you mentioned intelligence for IQ, right?
Yeah.
Yeah,
Sorry.
yeah. So there's nothing to be sorry about. You're perfectly fine. So IQ, I think, is a construct we have spent hours trying to unpack, whether be it inside our psychology classrooms at Ashoka or even in outreach courses and lectures. Um, there are interesting caveats to the concept of IQ and just equating that with smartness. So that's probably the first thing I'd um discuss. But even I was a little caught off guard by this one. And the way I thought, I don't know, Arpita, what you think about this, but we know that music fundamentally, I mean, this doesn't require neuroscience per se. Music moves people. It doesn't matter, if for someone, rap might do it, and for someone else, Mozart might do it, and for someone else, Indian classical music might do it. But music has an innate ability to move people emotionally, affect people. Sometimes, as Sana said on chat, we all use music while exercising, right?
Mm-hmm.
So, you know, even if not smarter, there are other brain processes that other than intelligence, right? Intelligence is one among all of your cognitive dimensions. There's attention, there's regulation of your emotion, there's so many different things. So intelligence is sort of, and that's why I wasn't sure which part of the statement to respond to. So that's why I focused more on specifically because you mentioned Mozart. So I don't think Mozart is superior compared to any other kind of genre in its ability to affect your brain.
Yeah.
Yeah.
I think so too. I think it's related in to regulation of how you feel than to like how you like than your intelligence per se. That is what you equate to being smarter. But yeah, I think how you feel can impact how you perform. So in some way it can be related though. And it doesn't have to really be Mozart, as Professor correctly mentioned. It can be any kind of music that you prefer.
But we also have a question from Vriti. She's asking, does music impact your brain because of the frequencies?
I think Professor will be good at answering this one.
I can try, but do you have any thoughts on this, Orpita? What are your thoughts? You're also a cognitive neuroscientist. What do you think? I'm not a cognitive neuroscientist per se, but I'll try to give you my understanding.
Is the question like about how, sorry, could you repeat it once?
Does music impact your brain because of the frequencies?
Yeah, I think the beat of the music can definitely like impact how you're feeling. For example, like if the frequency of the music, if I understand it correctly, if it's like not very fast, I think those kind of music is like used for um meditative purposes and to like calm you down in a way. But music that is like rap music and a lot of upbeat music is are like seen to like people mostly hear when they are like trying to uplift their mood. And I think there is significant amount of research that correlates like the beat of the music to how you feel. So in the gym, for example, whenever like you see like most people are hearing like loud upbeat music to like maybe uplift how they are feeling so that they can perform better in the gym in a way. But how it impacts brain oscillations, that's something that I need to look up. But it is definitely related to mood, the kind of music you hear.
Yeah, I mean, if you think about it, what is sound, right? Sound is, it's a wave. It has amplitude, it has frequency. These are the two fundamental characters of any waveform. It has an amplitude and it has a frequency, right? And pitch is whether the sound is dull, low register, or whether it is shrill or high register. So I think extremes on there's some research, for example, that certain low pitch sounds at very specific frequencies can provoke panic attacks in humans or even migraines. Certain frequencies, if you use, the strobe effect, what is called a strobe effect in lighting, in sometimes in lighting patterns, strobe effects can evoke seizures in people who have been diagnosed with epilepsy or epileptiform disorders prior. Um, it can bring forth manic or psychotic outbursts in individuals who have had diagnosis of bipolar disorder or schizophrenia, even. But these are all case specific. It doesn't
Yeah.
always happen because, the way we have to understand psychological disorders at the first place is that the same disorder can look very different in two different people. And in general, also, I think there is a lot of, I would say, with a high confidence that yes, frequencies do appear to have certain effects on how the brain processes information. And right now, we have one very exciting project going on in a different faculty's lab in our department who actually were able to show, and their data set, their musical stimulus set is entirely based out of Indian classical music. And now they are showing that certain ragas, when played to people, changes their GABA glutamate balance in the brain, which are specific types of neurotransmitters. So this is a very active area of research. So I would say, while I do not have an article that I can kind of cite right now at this moment about specific frequencies affecting specific domains of brain functions, I would but say it with a very high degree of confidence that it's an educated guess that yes, they do. But the patterns in which they can alter is again very situational and very contextual.
Yeah. Yeah, the pattern is something that is contextual, but I think there's a lot of literature connecting specific genres of music to how you feel. So that's something like we can all explore.
Yeah, even on Spotify has now specific, I hear that I even see that there are like breakup playlists versus exercise playlists, right? So we have people usually in their infinite collective wisdom figure these things out pretty well.
Yeah.
Did we actually answer your question, or did we kind of veer away into other areas which you were not asking about? I would just like to check whether this was the answer that you were in fact looking for.
Yeah, definitely. I mean, this is such a vast topic, and I am just, trying to grab at any information I can. So, yeah, thank you so much for sharing.
Yeah. So I think we correctly, like everyone like was correct in this place. Mostly like it's a neuro myth. As someone said, it magically cannot make someone smarter, but it definitely impacts mood and alertness and how you feel.
Yeah, 5 years ago, I would have told you to go and find out this book called Musicophilia, written by Oliver Sacks. But lately, I have been more cautious in recommending Oliver Sacks' books to students because it turns out a lot of things he wrote about were not very robust. So,
Mm.
yeah, there was a big article about that on New York Times, Arpita. I don't know whether you have seen it, but apparently a lot of stuff that Sachs wrote about weren't exactly robust, or he kind of colored them a little before he put them in his books. So that made me quite sad.
Yeah, because it's such a famous book, though. Yeah.
And he's such a rock star in neuroscience, right? Oliver Sacks is one of those celebrity neuroscientists, neurologists whose books we have literally grown up reading.
Yeah. Sure, do we move on to the next activity, or would you like to take part, like start the concluding session?
I was just gonna ask because we are a bit short on time. I
Okay.
did want to check with you with the memory game. How much time do you think we would roughly need?
That's really quick. I can start that and like conclude it if you like. Yeah.
Then I
Oh,
think most
this
of
is
the
the DRD list. Yeah, protocol, the DRR protocol. Yeah, all right.
yeah.
Okay. Yeah.
Okay, so should I go on to the memory game? Okay. Yeah. Okay, so for this part of the activity, you will see a few words come up on the screen for exactly like maybe 7 seconds. And then we'll have the memory challenge. So you can't write any of the words down. It'll be like a quick flash and it'll go away. Okay, so here are the
No
words.
screenshots either.
Oh my God, yeah, I forgot about that. Okay, now scan this QR code. And like type as many words that you can remember.
Can you share the link as well? I'm not able to open the QR code.
I've just shared the link on the chat box, and then you should be able to join in.
Okay, thank you.
Has everyone gotten the link? Okay. Do you think sleep was there on the list, maybe? Is everyone able to see the slide?
Yes, we can see the slide, but I don't think we have the voting option. So we have responses coming in through the chat box. Sana is saying no. I am saying yes. Sheetal is saying no. Anvika is saying no. Virat is saying yes. So we
Okay.
have about 3 no's and 2 yeses. One more no coming in. I think most of the attendees seem to be saying no, whereas your fellow panelists have been saying yes.
Okay. Uh, I think unlike the last learning circle, everyone is very smart in this one. Or I don't know if you guys have taken screenshots or something. Okay. So sleep was actually not there on the list, but like in the last learning circle, like a lot of the students said that sleep was apparently on the list. And that is essentially because the brain is like tuned to forming patterns in between the words and you see semantically and fill in the gap when there is a missing information. Like when you're asked to say if sleep was there on the list or not, the brain will apparently, the brain will automatically link um, try to find the missing word by linking it to the existing words that could have been there. And based on that, basically, you would either give an answer that is yes or a no. But I think you guys were very smart to like know already that sleep wasn't on the list. And
Already,
because
we
all the
have
words,
already done this in school. I mean, this is the DRR is quite common, but I think we are still on point in the sense only about 25 to 30% people are show this kind of misinformation effect anyway. If I remember Loftus's claims, it's about 25% to 30%.
yeah. And this activity was essentially to help understand how the brain can fill missing information and by connecting what was asked to like existing information that was already there and how memory is reconstructed using meaning, context, and what you expect to be there in that specific context. So basically, patterns are formed patterns are like formed looking at existing information to fill in the missing information essentially. So this is very important for well-being because our brain does the same thing in certain situations when we do not have full information about something. For example, we often think that like when someone is not responding to us, we think that they are ignoring us. And if you make a mistake, we feel like, okay, we are not good at this. The brain kind of fills information in our like automatically kind of based on information that we have not directly provided it to it, but just based on the context. So the point is that our brain is not always wrong all the time, but the brain can make predictions, and those predictions may not always be right. And that the predictions it makes like impacts our well-being. Sometimes they lead to a lot of stress. So a part of well-being is to like actually determine if the predictions the brain is making is actually what has happened, or is the brain adding something based on our past experiences and the patterns that it has recognized. Okay. I think we are ready to like get to the concluding session.
Perfect. Thank you so much, Arpita. I'm going to let you take over this slide, share what is exciting to you about what you're going to be teaching in the coming few weekends, and then we can actually start the conclusion. Yeah.
Sorry, I think you cut off for me.
Okay. Okay. Am I more audible now? Is it
Yeah.
okay? Perfect. So yeah, thank you everyone for joining us today. I think you've gotten a glimpse, a very short glimpse into the psychology, neuroscience of well-being classroom. It's going to be highly interactive with a lot more activities and learning to do. I think there's a lot of takeaways that I've had as well in terms of, every single time I don't get a response to an email, I'm just like, someone is not checking their email box or they're just, deprioritizing it. Whereas there are so many more reasons possible for the same as well. And I think that kind of showcases how our brain tends to fill up uncertainty with very different kind of thoughts as well. And learning more about that can actually really help us in navigating this uncertain world right now, because there is a lot of uncertainty around us all the time. So I think some of the takeaways that students have had through the course have not just been academic and professional in nature, but also personal in nature, because it's helped them regulate their own emotions and learn more about it. I think that's the beauty of learning a subject like psychology. As a student of psychology myself, I can emphasize that this course, it was something that if I was in ninth grade, I would be doing it for sure. I think I'd had a long-standing interest in the same. The classes are starting super soon from next weekend onwards. We're actually closing applications this Sunday. So if you're interested in doing the course, please fill out your applications as soon as possible. It's a very simple process. We also have courses happening across two editions. So in case the May dates don't work for you, you also have the June and July courses to look through. We'll also share the link with you in the chat box as to learn more about the courses. And towards the end, I just want to raise an open question to Professor Simantani and Arpita as to what is one thing that you're looking forward to the most in teaching this course to the students this summer?
Arpita, I'll let you go first. Then I'll.
Sure, like I'm really looking forward to interacting with the students and conducting the activities that we do in the Sunday sessions. I think I have a lot of fun doing the activities with the students in class. And while talking about neuroscience and well-being together, I think that's one thing that I'm looking forward to, like a lot of interactive activities that'll be hands-on, and we'll get to know each other, talk about different things, about different concepts related to well-being and how the brain works in regulating emotions and so on. Yeah.
All right. I think I come with a of course, I mean, interacting with students is always a great thing. That's why I do what I do. But I am very enthused about getting people all excited about brain and how the brain functions and how, you know, people, how it really it's rather extraordinary, right? That from a tangible organ, you're building something that's totally intangible. That is your psyche, your consciousness, which is something that's so vast and so abstract. It's unimaginable that a tangible organ can create a whole universe that is you, right? So that's the thing that this excitement is what, and this wonder is what keeps me going and fuels my passion for this subject. And I think the most um, inspiring and the most gratifying thing for me is when students get a glimpse of that excitement. If I can get them curious and if I can get them excited about this stuff, then my job is done. There's no reason, if you're not a science student, that you cannot do psychology. There's no reason, if you don't like biology, that means you have not been introduced to how fun biology can become, right? So it depends a lot on the instructor. So my job is to get you excited about this. So that's the part I am excited about.
Yeah, and
That's
it's
so
always very interesting to like hear questions the student have in like the different classes, and that's something like we always look forward to, what you want to know even after we've given you, like after we have done these activities with you, after we have spoken to you, like the curious questions that you have, that really like keeps us going and keeps us motivated to like interact more.
That's so beautifully put, Professor Samantani and Arpita. I think I'm personally really excited for the activities that you guys have planned. The one of the activities that you did last year was a huge hit. I'm not going to name it right now because I don't want to spoil it for potential students who have joined us in the webinar today. But as we mentioned, we've shared the links in the chat box. I'm just going to open up the session for a short Q&A right now. So if you have any questions right now, please feel free to unmute yourself. If you don't have any questions, I'm going to start with the concluding remarks. So now is a really good time to, raise your hand, ask the question that you may have. It may be related to what are the futures or what is the future of psychology. It may be related to what are the careers available in it. It may be related to why is Mozart someone who can actually really help us in becoming smarter as well. So related to the activities. Or you can ask, why did we do so much better in the learning activity as compared to last year? So yeah. Yes, Ruthie, go ahead.
Hi, so I wanted to just like know what your view is on like autoimmune diseases and like stress how mental health impacts diseases, especially autoimmune diseases.
Also, this is something that I actively, not autoimmune disorder, but I am a neuroimmunologist by trade. So my PhD's focus was on studying a immune molecule called IL-1 beta, which is also primary driver of inflammation in the brain. And it is stress is basically a huge fact. And one of the things that we have always known as clinicians is that people who are diagnosed with common psychological disorders, like which consist of any kind of anxiety disorders, or to say depressive disorders, or post-traumatic stress disorder, they have this kind of sub-threshold inflammation, signs of inflammation in their blood. All cytokines, what is inflammation? We understand the word swelling is a commonly term that we substitute with inflammation, but what we always sometimes do not remember is that it's a reparative response. The job of why does inflammation happen is because your immune system is actively not only trying to fight off an infection, but it's also simultaneously upregulating processes that will repair the damage. So inflammation is like a double-edged sword, the way the science is telling us. And it is a big question actually, what you asked in autoimmune disorder. How is it all related with inflammation? Multiple sclerosis is the canonical neurological inflammatory disorder in which our own immune cells attack the myelin, right? So the full answer is not yet known. It's a very active area of inquiry, particularly in multiple sclerosis. Richard Ranshoff's group has done wonderful research, I think, through the last 30 years, identifying the different cell types that are important. So he is at Cleveland Clinic. You can look up his lab page if this is something that interests you. And it is a big deal in stress. We test out social and physical restraining stress in rodents, and its link to their blood cells and the inflammatory markers in their blood and in their brain, and it goes through the roof in stressed animals. Whether they are physically restrained or whether they just suffer something that we call it a social defeat, which is basically left alone with a much more aggressive and larger rat that tends to scare them. And it's not that the larger rat can physically harm them, because after 10 seconds, we put a wire mesh separating the test animal from the aggressor animal. So it's only them seeing the aggressor trying to attack through the mesh is all it takes to lead to this over the top inflammatory responses in their brain, in their blood work, in the blood cells, everywhere. So active area of investigation, a lot of work is being done trying to interfere and interrupt this inflammatory upregulation to see whether that does anything to mitigate the response, the depressive behaviors or the anxious behaviors that we can model in animals. So it's a very active area of research.
Okay, thank you.
Mhm.
Do we have any last questions for our esteemed panelists today? And thank you, Rudy, for such an interesting question. I think that's something that I've been reading about a lot as well. So it's been great to get the input from Professor Samantani for the same. All right. In case you guys have any questions, please feel free to email us at the email address that we've mentioned in the chat box. It's horizons@ashoka.edu.in. We'd be happy to take forward the questions to Arpita and Professor Samantani as and when they come. Thank you so much, Professor Samantani and Arpita, for joining us today and conducting these really fun activities that kind of gave us a little window into our brain as well. And thank you for all the attendees for engaging with us.